Okay, we're back, and I don't know if you guys can see this, but there's steam coming out of the can that's been sitting on the hot plate. You may be able to hear it cracking too. And what's going on now is the little bit of water that was put at the bottom is changed into water vapor. And I want to remind you guys that gases want to take up as much space as you'll let them. And so the reason why these water vapor molecules are coming out the top of the can now is because that's where the space is. They're escaping the can. So we're going to assume that there's a lot more water molecules inside of the can that are trying to escape. They're a gas, and they're trying to get through that little opening at the top. Well, what I want to do now is create some forced condensation. I'm going to be taking the can in just a minute. I've got some tongs with me, and I'm going to be putting the can very quickly into my container of cold water. Remember, there was snow in here, right here, from out behind school. There goes my lab assistant, Zoe. She's here with me today. There she is. And what we're going to do is we're going to look at what happens when I very quickly change the water molecules from a gas, which is what they are right now in this can, back to a liquid. So I'm going to be taking my tongs, because the can is extremely hot. It's metal, it's been sitting on a hot plate. I'm going to be taking it, flipping it upside down into my container of cold water. And that decrease in temperature is going to quickly change these molecules from a gas to a liquid. So let's see what happens. There you go. The can crushed. Pretty amazing. I didn't squeeze it at all with the tongs. I promise you, this thing is toast. It is crushed. And now we want to talk about how air pressure plays a role in how this can was crushed.